In our previous videotapes, we have been reviewing fractions, decimals, and percents. Now, it's natural to wonder what you can do with all this. In this videotape, we're going to be discussing some real-life word problems. Okay, real-life problems that you can solve using what we've already learned about fractions, decimals, and percents. Now, all of the problems that we'll be going over today are available to you on a printed piece of paper in the math lab. So before you start this videotape, or you can stop it right now for a moment and go over to the math lab supervisor and get a copy of the problems that I'm going to be working out. It'll save you time if you don't have to first write down the questions. Okay? So stop me, get a copy of the sheet, and then come on back and we'll start the tape. Okay, the first problem on your sheet is the following. Each batch of cookies calls for 1 1/3 cups of sugar. If Eve has only 4 cups of sugar available, how many batches of cookies can she make? Okay, now there are 2 problems that you have to deal with in this question. First problem is you have fractions, and the second problem are the words. People don't like too many words in their math problems. Let's simplify it a little bit and see if we could have solved it without the fractions. Let's say each batch of cookies called for 2 cups of sugar. Well, if you needed 2 cups of sugar in each batch and you have 4 cups of sugar available, you could figure out how many batches of cookies you could make. You need 2 cups for each batch, and you only have 4 cups. So you have to say how many times does 2 go into 4? 2 goes into 4. 4 divided by 2 batches is all you can make. Okay, so what did you do? You tried to figure out how many times 2 went into 4. Well, here it's the same idea, except we want to figure out how many times 1 1/3 goes into 4. Instead of 4 divided by 2, which was easy, we have 4 divided by 1 1/3, which is not so hard. 4 divided by 1 1/3. We want to know how many 1 1/3 are in 4. How many 1 1/3 are in 4? Just like if there were 2 cups of sugar in a batch, we want to know how many 2s were in 4. So now we want to know how many 1 1/3 are in 4. Well, that's 4 divided by 1 1/3. 4 divided by 1 1/3. This can be written this way, or it could have been written 4 divided by 1 1/3. Either way, 4 divided by 1 1/3, or like that. This is 4 divided by, now let's change 1 1/3 into a regular fraction from this mixed number. It's 1 times 3 plus 1, which is 4 over 3. 1 times 3 plus 1 all over 3. 1 1/3 is basically 3/3 and 1/3, or 4/3. 4 divided by 4/3 gives us 4 times, instead of dividing by 4/3, you invert and multiply by 3/4. So instead of 4 divided by 4/3, it's 4 times 3/4. 4 over 1 times 3 over 4. And the answer is, now you can cancel the 4s, divide numerator and denominator by 4, for a final answer of 3. So how many batches of cookies can she make? She can make 3 batches. Here, if you didn't cancel the 4s, you would multiply the numerators, divide by the product of the denominators. You would have had 12 over 4, which was also 3. But we know from our work in fractions that it's helpful to reduce prior to the multiplication. So we canceled the 4s, we got 3. We wanted to know how many 1 1/3 were in 4. 4 divided by 1 1/3, 4 divided by 4/3, 4 times 3/4, for an answer of 3. She can make 3 batches of cookies before she has to go out and buy some more sugar. Problem number 2 says Jack works 2.5 hours each afternoon from Monday through Friday. If he gets paid $3.75 per hour, how much does he get paid in a week? Okay? These are practical problems, the kind that you might run into, okay, in your everyday life involving, as I said, fractions, decimals, and percent. Okay, let's say this was your part-time job after school. 2.5 hours each afternoon from Monday through Friday, so for 5 days every week. You work 2.5 hours each day, and we know your hourly salary. So we're going to have to multiply some things together here. We have to take the hourly salary, the number of dollars per hour, multiply that by the number of hours per day times the number of days per week that he works. To get the total number of hours, we need to get the total number of hours he works in a week and then multiply by the hourly salary. Okay, each week he works, let's see, 2.5 hours times 5 per day times 5 days. 2.5 hours per day times 5 days, right? How many hours? First figure out how many hours he's going to work, and then we have the hourly salary. We'll figure out what he gets per week. But each week he will work 2.5 hours per afternoon times the 5 weekday afternoons. So 2.5 hours per day times 5 days per week. So each week he works, now, 2.5 times 5 is 2 times 2, 4 plus 1, 5 halves times 5, or 5 halves times 5, that's 5 halves times 5 over 1, or 25 halves hours per week, or instead of 25 halves hours, people sometimes say, when should I leave it as a improper fraction? When should I change it to a mixed number? Very often in word problems, you want to write it as a mixed number. If someone says, how many hours a week are you working? You generally don't say 25 halves hours a week. You would say 12.5 hours per week. Each week he works 12.5 hours. Okay, well, that tells me how many hours a week he's working. Now, he's making $3.75 per hour. So we want to know how much does he get paid in a week. So his weekly salary will be the number of hours he works per week, 12.5 hours per week, times $3.75 per hour. 12.5 hours per week times $3.75 per hour will give us his weekly salary. Now, we can multiply a decimal times a fraction. However, you might find it easier to say 12.5 hours per week times $3.75 per hour to get the final answer in dollars. $3.75 per hour times 12.5 hours per week. Okay? 3.75 times 12.5. Now, 5 times 5, 25, carry the 2, 5 times 7, 35, and 2, 37. Put down the 7, carry the 3. 3 times 15, 3 times 5, 15, and 3, 18. 2 times 5 now, 10. Put down the 0, carry the 1. 2 times 7, 14, and 1, 15. 2 times 3, 6, and 1, 7. And finally, 1 times 3, 7, 5, so 5, 7, and 3. Adding in columns 5, 7, 8 and 10, 18, 2 and 7, 9, and 7, 16, 1 and 3, 4. Okay, before you start thinking what a terrific job this guy has, remember that the number of decimal, where you place the decimal point in the answer depends on the number of decimal digits you have in the factors. There were 2 decimal digits here and 1 decimal digit here, 2 plus 1. So the answer has 3 decimal digits. Okay, so 1, 2, 3. So he makes $46. Okay, 46.875, rounding it to the nearest dollar, rounding it to the nearest penny, excuse me, $46.88 per week. 46.875, rounding it to the nearest cent. Okay, this is 5 or more, so we make it $46.88. Okay, he worked 2.5 hours each afternoon from Monday to Friday. He got $3.75 an hour. We wanted to figure out how much he made per week. What you have to do is let yourself go and to figure this problem out as if it was your money, you'd know how to figure it out. First, you figure out how many hours he's getting. Okay, 2.5 hours a day times 5 days a week. That's 5 halves times 5, 25 halves, which was 12.5 hours a week he works. 12.5 hours per week, and his hourly salary is $3.75 per hour. So 12.5 times 3.75. You could have left this as a fraction times a decimal, but I thought it would be a little easier if we just made it a decimal times a decimal. We went over, we did the multiplication. We got $46.88 per week. I have the third problem ready now. Susan goes to an appetizing store and buys 2.5 pounds of cheese at $3 per pound, a half a pound of cashews at 10 cents per pound, and 3/8 of a pound of smoked salmon at $16.80 per pound. How much change does she get from a $20 bill? Once again, this is the kind of problem that you might run into in a real-life situation. Okay, let's first figure out how much she pays for the cheese. She has 2.5 pounds of cheese at $3 per pound. So for the cheese, she pays 2.5 times 3, that's 5 halves times 3 over 1. That's 15 halves. And once again, there's nothing wrong with 15 halves, but I think we would prefer 7.5. If we're talking about dollars, we understand for the cheese, she pays $7.50. $7.50 or $7.50. Okay. A half a pound of cashews at $4.10 a pound. Okay? 1/2 times 410 over 1. That's basically how many times does 2 go into 410. 410 divided by 2, which is, of course, 205. So for the cashews, she pays $2.05. Now she's also going to buy 3/8 of a pound of smoked salmon times $16.80 a pound. Okay, that's 3/8 times 16.80 over 1. Once again, you can do the multiplication and then divide, but it's easier to try to reduce if we can first. We can divide 8 by 8 and get 1, and 1680 divided by 8 gives us 8 goes into 16 twice, into 1, into 8 once, so 210. So 3 times 210, or $6.30 on the smoked salmon. So for the smoked salmon, $6.30. Let's go over what she spent. 2.5 pounds of cheese at $3 a pound, 1/2 pound of cashews at $4.10 a pound, 3/8 pound of smoked salmon at $16.80 a pound. Performing the multiplications, we saw that she spent $7.50 for the cheese, $2.05 for the cashews, and $6.30 for the salmon. So total spent was, the decimal point in the answer under the decimal point there in the problem, 5, 5 and 3, 8, 7 and 2, 9 and 6, $15.85 is what she spent. Now she gives him $20 bill, and the change, she spends $15.85. Gives him a $20 bill, and let's figure out the change. Decimal point in the answer, right under it in the problem. You line up the decimal point. 10 minus 5 is 5. 9 take away 8 is 1. 9 take away 5 is 4. 1 take away 1 is 0. So $4.15 in change. So we figured out what she spent on the various items, add it all up. That's the total spent, and the change from the $20 bill turned out to be $4.15. Okay, this is a problem many of you may have faced with your cars. It says Josh feels his car is not running well, and he wants to check how many miles he is getting to the gallon. He fills up his car at the service station with 15.2 gallons. He notes his odometer at this time reads 30,211 miles. That's the mileage on the car. A week later, he again fills up his car. This time it takes 13.4 gallons. His odometer now reads 30,500 miles. How many miles is Josh getting to the gallon? Okay, now, actually, not every piece of information that I gave you will be needed in solving the problem. It's up to us to figure out what we need and what we really don't need. Okay? Basically, if you want to figure out how many miles he's getting to the gallon, you have to know how many miles he's gone and how many gallons he's used. Then you can divide the miles he's gone over, divided by the gallons he's used to get the miles he's getting per gallon. Okay, now in this time, and the key here is the filling up business. He fills it up and he fills it up again. If he doesn't fill it up, it will be hard for him to figure out exactly how many gallons he's used. So he goes to the service station the first time. Actually, this is not needed, the 15.2. I'm throwing it in here, but it's really not needed. The important thing is he starts by filling up his car. Okay, the 15.2 gallons here is not important. He needs to know he fills it up, and he starts with 30,211 miles. A week later, and the time, of course, is not important, he again fills up. That's important. Okay, if he fills up and he fills up again, then we can be sure that if it took 13.4 gallons, that's exactly what he used to go from 30,211 miles to 30,500 miles. So he has gone. He's traveled. Originally, he was at 30,211 miles. Now he's at 30,500 miles. So he has traveled 30,500 minus 30,211. Subtracting, we get 10 take away 1, 9, 9 take away 1, 8, 4 take away 2, 2. 289 miles. Okay, he's traveled 289 miles, and he has used 13.4 gallons. Okay, when he fills it up, that he can see that he's been given 13.4 gallons. Okay, but if he hadn't filled it up the last time, that wouldn't be useful to us. The fact that he started with a full tank, and this time he takes 13.4 gallons, that's exactly the amount of gas that he's used in going these 289 miles. Okay, so he has gone 289 miles, and we know he has used, okay, in 289 miles, he has used 13.4 gallons. So if we want to know the miles that he's getting per gallon, we will divide 289 by 13.4. 289 divided by 13.4 to get the miles per gallon. This is the number of miles he's gone, the number of gallons of gas. If we divide, we'll figure out how many miles he's getting to the gallon. Now, in the tape on decimals, we learned that in order to divide by a decimal, we really have to first modify the problem so we're dividing by an integer. To accomplish that, we multiply the numerator and denominator by the appropriate power of 10. So what we're going to do here is to multiply the numerator and the denominator by 10. Okay, and that will shift the decimal 1 point to the right. So 13.4 times 10, we can multiply by 10 over 10 because that's like multiplying by 1. The denominator is now 134. The numerator is 2890. We shift the decimal point in the numerator and the denominator one place to the right. So that becomes 13.4 becomes 134. This becomes 289 and a 0. So now what we really want to do is to figure out how many 134s are in 289. Okay? 134 into 289. Excuse me, 2890. Put the decimal point over in the answer, right over it here in the dividend. Some people, by the way, prefer to do this more automatically. They go 13.4 into 289. And they say, I can't do the problem unless I'm dividing by an integer. I need to move my decimal point one place to the right here, and I move it one place to the right here, and then they start the problem. That's fine. But basically the same idea. It's going to be 134 into 2,890. Okay, how many times does 134 go into 289? It goes twice. 2 times 134 will be 268. Subtracting, 9 take away 8, 1, 8 take away 6, 2. Bring down the 0. How many times does 134 go into 210? Once. 134, subtract. And of course, use as many zeros as you need there. 10 take away 4, 6. 10 take away 3, 7. Bring down the 0. How many times does 134 go into 760? It goes basically 5 times. 5 times 134 comes out to be 4 times 5, 0. 3 times 20. So you put down the 0, you carry the 2. 3 times 5, 15, and 2, 17. Put down the 7, carry the 1. 1 times 5, 5, and 1, 6. Subtract, and you get 90 and bring down another 0. How many 134s in 900? It goes about 6 times. Once we see this number is over 5, we can see that he's getting about 21.6, rounding to the nearest 10. He's getting 21.6 miles to the gallon. which is not that bad. Okay, let's go over the problem. You had to figure out the mileage here, how many miles he's getting to the gallon. You'd have to know a certain distance that he's traveled and how many miles of gas he used. One way of accomplishing this, okay, is to fill your car up, okay, record the mileage. Fill it up again sometime later, record the mileage and see how many gallons went in. Then you will know that to go from this mileage to that distance, you used that number of gallons. You then divide the number of miles you went by the number of gallons you used, okay, to get the miles per gallon in this case. He covered 289 miles with 13.4 gallons, and that meant he was getting 21.6 miles to the gallon. Okay, in problem number 5, which you have on your sheets, Steve's weekly take-home pay is $210. If he budgets 40% of his money for rent, 20% for clothing, 35% for food, and the rest for entertainment, how much money can he spend each week on entertainment? When you work this problem out, you may decide that Steve should move to a cheaper apartment because he's not going to have all that much money left for entertainment. Okay, but this is a situation that you might find yourself in. Okay, now it's 40% for rent, 20% for clothing, 35% for food, and the rest for entertainment. Well, how much have we used up of the total, which of course is 100%? Okay, 5, 4, and 2, 6, and 3. 95% is used up on rent, clothing, and food. That leaves 5% is left for entertainment. So what we need to do is to figure out what is 5% of $210. Going back to the way we studied percent problems, if we try to set up a proportion, x is to w as p is to 100. The percent in this case is 5. The whole salary is the $210, and we're looking for the part that he can spend on entertainment. X is the part, W is the whole, P is the percent. So X is to 210 as 5 is to 100. X is to 210 as 5 is to 100. Cross multiplying, which is how we solve this, we get 100x is 210 times 5, which is 0, 5, 1, oh, okay, 1,050. Then, dividing both sides by 100, we can figure out the amount that he can spend on entertainment. To divide by 100, we move the decimal, which is in an integer, it's assumed to be to the right of the number. 2 places, we move the decimal 2 places to the left to divide by 100, and we get $10.50. Okay, so he can spend $10.50 each week on entertainment. We want to figure out 5%. We see that he has used up already 95% of his money on these fixed expenses. Okay, if nothing is going to change there, he will only have 5% left. 5% of $210 can be found. You can either multiply 0.05, which is the decimal equivalent of 5%, times 210, and get that, or set up the proportion, which works on basically all of these percent problems. X is to W as P is to 100. And P is the percent is the 5. The whole is 210, and we're looking for the part of the whole that he can spend on the entertainment. And it turned out to be $10.50. Okay, in problem 6, we have the following. Joan buys a jacket which costs $75. That's the selling price. The sales tax is 8.25%. What is the total price that she has to pay for this jacket? Okay, well, you can figure out the tax separately and then add it to the $75. Later on, I'll show you another way where you could do just one calculation to work out the whole thing. But if you want to work out the sales tax separately, the sales tax we need, okay, is 8.25% of $75. And that's what we're looking for, the sales tax. If you go X is to W as P is to 100, okay, you need to figure out really what is 8.25% of $75. The percent is 8.25, or you could write 8.25. This is the P. The whole price for the jacket was $75, and we're looking for the part you'd have to pay for sales tax. So X over 75 is 8.25 over 100. Cross multiplying, you would get that 100x is 75 times 8.25. Or 100x is now 8.25 times 75 can be figured out. 5 times 5, 25. 2 times 5, 10, and 2, 12. 8 times 5, 40, and 1. 5 times 7, 35. 2 times 7, 14, and 3, 17. 8 times 7, 56, and 1, 57. Adding up, 5, 7, 8, 1, 6. 61875. Now, there are 2 decimal digits here and no decimal digits here, so 2 decimal digits here. So that's 618.75. 618.75. And then dividing both sides by 100 to get x. X is, now to divide by 100, we move the decimal 2 places to the left, 6.1875, or the sales tax is $6.19. So, total price, you're going to have to add the cost of the jacket, which is $75, to the sales tax, which is $6.19, to get a final answer of $81.19 is what she has to pay for this jacket. Okay, now I want to mention that many of you would have an easier way of doing this. As I've mentioned, this X over W is to P over 100, works on all percent problems. However, many people simply multiply. In a case like this, we're trying to figure out the sales tax is 8.25% of 75. Now, to change 8.25% to a decimal equivalent, you drop the percent sign and you divide by 100. You move the decimal 2 places to the left. So you can multiply 0.0825 times the $75. Okay, you could work that out, and that would come out automatically to the 6.1875 or the $6.19 that we had gotten earlier. Okay, so you would have had, if you want to, you can say 0.0825. That's the 8.25% equivalent in decimals. You drop the percent sign, you divide by 100. You move 2 places to the left. Okay, 0.0825 times 75, $6.19 for the sales tax, rounded to the nearest cent, and you add that to the price of the coat. Or some people, what they do is they multiply this. In other words, they know that what they're going to need is the price plus the tax. Now, the price of the jacket was $75. The tax is the 0.0825 times the cost of the jacket. So it's the price of the jacket plus the sales tax. And what they do is they factor out a 75, and that leaves us with 1 plus 0.0825. So if you instead multiply 75 times 0.10825, you will get automatically the 81.1875, or the $81.19. So if you find that more convenient, if you want to work out the total price at one time, you can take, instead of multiplying by the 0.0825, 1 plus the 0.0825, in other words, the cost of the jacket plus now the sales tax, done in one calculation. Okay, but if you are having trouble with this, remember you can go back to the X is to W is to P is 100, figure out the sales tax, add that to the $75 that the jacket cost to get the total price paid for the coat, $81.19. And that brings us to the end of this tape.